complex number. Now, this video is again on like chapter of 11, from class 11 complex number, because before of this 3 videos are done like properties of the complex number and the different like operation of the complex number, addition, subtraction, multiplication and division. Okay, and then properties of iota like I to the power 4, I to the power 3, I to the power 2 and then I, and so many operations related to the complex number is done. And now another topic in the previous video I discussed conjugate of complex number. So in this video I explain about the conjugate of complex number, because first here we define conjugate of complex number. So definition of for conjugate of complex number is you know that z equal to a plus ib here and be a complex number, and then the conjugate of z, and z is denoted by z bar and it's equal to z bar equal to a minus ib. Okay, any complex number is given, we know that is a form of real and imaginary. Like we discuss about the general complex number, we know that z equal to a plus ib, and z equal to a plus ib, in which a and b are the real numbers, and iota, that is I, including I into b. So I with any number is imaginary. And then how we find the conjugate? So conjugate is denoted by the one particular term according to the z. Like here we have a complex number, so z bar for the conjugate of complex number, so there is no change, only z bar is a minus ib. A minus ib means it's change the sign of I only. Okay, you have any complex number and then you change their iota, like plus sign is given, then you convert into the minus, or minus sign is given, then you convert into the plus. That is only the conjugate. So conjugate has the particular one. So many examples here we listed, with the help of this definition here we find out the conjugate. Like you have z equal to 3 plus 4i. Okay, so plus 4i is important. Okay, and their sign is important. And now we find out conjugate, then change this I of sign plus, so now convert into the minus after conjugate. Okay, so you have the complex number and then you convert into the conjugate, then only the change sign of I they are converted, like plus or minus here. Similarly, z equal to minus 5 plus 6i. So this is important. This value is not important here, plus sign or minus sign. Only sign of I is important, and now plus 6i is here, so you put or you convert into the minus 6i. So that is the conjugate of this number. Okay, then another example, because here we discuss the more example related to the same. And now we have the another complex number minus 7 minus 8i. So now again you underline what is I here, I with the minus sign. So now we convert into the plus sign, plus 8i. So now it is converted into the conjugate form, and now here we denoted z bar, and z bar is a conjugate of complex number. Similarly, in fifth example we have only a term of I, like z equal to 8i. There is no two terms are given here, only 8i. So now we find out conjugate of this 8i, so it is minus 8i, because only the change this sign here we convert into the minus. Plus is minus and minus is plus. And now sixth example again we have here discussed like minus 11 minus 12i. So now here value is minus 11 plus 12i, because sign are convert only. Minus sign convert into the plus sign. Okay, similarly seventh example, both are minus, so one only this sign is changed into plus. So here minus 39, now you find out conjugate, then it is plus 39. Similarly, eighth example only 12 is given. Okay, then z bar it means conjugate of this value, there is no change, because in this question complex number is not given with the iota, and in conjugate only change the sign of iota, but here iota is not given, so your number you put as it is, so there is no change. Z and z bar you have the same value. Okay, so ninth question again we have the same, we have the real number and then there is no change in the conjugate, so minus 8 you put as it is. And similarly one last example here we discussed like in the form of root, like root 3 minus root 5i, and now here minus sign is given, so it is converted into the plus, so plus root 5, and minus this root 3 you put as it is. Okay, so So many examples, 10 examples have we discussed, so that is not lengthy going only. The conjugate is meaning of only change the sign of I. Change the sign of I, it means you have any complex number, you want to find their conjugate, it means you change their sign of I. If plus I is given there, then its conjugate is minus I. If minus I is given in complex number, then its conjugate into the plus I. So that is nothing, only one part you including or remembering. For the finding the conjugate only, you have the z equal to a plus ib, then z bar equal to a minus ib. This much only, and 10 examples here we with the help of the same definition, and now we find out conjugate of complex number. Okay, so this is the simplification of conjugate. Now some properties that are related with the conjugate. So now discuss here some properties of complex number related to the conjugate. Okay, so now here we discuss z, z1, z2 are the complex number, and then z equal to a plus ib, z1 equal to a1 plus ib1, and z2 equal to a2 plus ib2. Okay, so this is the definition of complex number, because here we define z, z1 and z2 are the complex number, and then also we show out their meaning. What do you mean by z, what do you mean by z1, and what do you mean by z2? So similarly there are 10 properties here, so define here like one. First is conjugate of conjugate. It means you find out any complex number of conjugate, and then again you find their conjugate, then your complex number you put as it is like z. Okay, so any complex number of conjugate is again complex number. Okay, and second definition is z plus z bar. It means now you have the complex number and you add with their conjugate, then you have the real part of the complex number, because imaginary part are cancelled out there. We show out with the example, but first initially we have to discuss about only the properties, because with the help of examples I also listed like z plus z bar, how it is 2 times of real of z. Okay, so the only here we discuss like definitions and then properties, and then we have the example, and then we find out all this property with the help of examples. So z plus z bar, we have like 2 real of z. Similarly, any complex number you subtract with their conjugate, then you have 2 times of imaginary of complex number. I means imaginary and re means real number. Okay, so this is nothing, this is the same thing. And now fourth property, z equal to z bar. Any complex number which is equal to their conjugate, and then if and only if z is purely real. Okay, here we have the example like 9th example and 8th example. Z equal to 12, z bar equal to 12. So there is no change. Z and z bar both are the same. So property number 4 is example of this 8 and 9, because there is no change and no iota here, so it is a purely form. So z is always purely real in case of complex number and conjugate of complex number both are equal. Okay, then fifth property, complex number plus addition of complex number is 0. Okay, now you have the same property second and fifth, but in second property and fifth property have the difference. Like here z plus z bar is 2 times of real of z, but here z plus z bar is equal to 0. Okay, so if you add this property, then it is purely imaginary. It means there is no you have your whole value is 0. Okay, you find out any complex number and the answer will be 0. So in this case you have the pure imaginary part of the complex number, right? And then sixth property, z into z bar. Z into z bar, it means complex number multiply with their conjugate, then it is real complex number of whole square plus imaginary complex number of whole square, because we know that z equal to a plus ib and conjugate of complex number a minus ib, then a plus ib and a minus ib, they are multiplied. We know that they form the identity of a plus b into a minus b. We know that a square minus b square. Similarly, we have the same property and same numbers like real of z of whole square plus imaginary of complex number of whole square. So there is no change, I think you know. the property related to the same thing here. Okay, then 7 is z1 plus z2. Okay, you have two complex number and then you find out whole conjugate, or you find out separate their conjugate and then you add. So their properties will be same. There is no change like first you add and then you find conjugate, or you find conjugate and then after you add. There is no change in your operations. The operation will be same. So same properties 7 and 8, because this property is related with the plus sign, this property is related with the minus sign. Your operation will be same. Z1 plus Z2 bar, or Z1 minus bar, Z2 minus bar. Again you have the same like your conjugate of sum of two complex number is sum of conjugate of their separation will be again added, then result will be the same. Okay, so same property here. So same for again multiplication and same for the division, because in multiplication z1 into z2 you find out whole conjugate, or you find out z1 conjugate into z2 conjugate, result will be same. The same last property you have discussed, like you have two complex number, you divide z1 by z2 and then whole conjugate. Otherwise you find out separate their conjugate and then divide in case of z2 is not equal to 0. So these are the 10 properties related to the conjugate of complex number. So I think these all properties are very easy. And now suppose you cannot understand about the properties like how it comes, and then here we will take the examples like this 8 properties and discuss the same. If we have the result, their properties they are equal or not, here we discuss out. Okay, then we have the like this all properties defined with the help of example, or using the like same given general term. Like first property you write down here like LHS is Z bar of bar. Okay, so we know that Z first here we write down A plus IB of bar. Okay, and then whole bar. We know that one conjugate inside, because since Z equal to A plus IB and implies Z bar equal to A minus IB. Okay, so you have inside like A minus IB and now again bar. So again change of this sign. So again you have A plus IB. So this is Z. So this is the RHS. Okay, because one time you have the conjugate sign, one change sign. Like one sign is changed with this I is minus, and then again conjugate sign is here. So again this sign of I again change, then it is converted into the same. So we know that now here A plus IB is A plus IB, that is Z. Okay, then second property. Again you write down the LHS part, Z plus Z bar. Okay, so Z is, we know that A plus IB and then plus A minus IB. Similarly, A plus IB plus A minus IB. So this term is cancelled out. A plus A is 2A. So A is purely real. So this is of real of Z. Okay, so therefore you have the right hand side. The property is same, Z plus Z bar, because here we discuss like Z plus Z bar is 2 times of real of Z, and here RE means real of complex number, so we have the real of complex number because resultant value is without I, therefore it is real. Okay, and then the third property, Z minus Z bar, so A plus IB minus A minus IB, and then A plus IB minus A plus I into B. So A cancel out. So it is 2B of I. It means 2 times of imaginary of Z. This is the RHS. Okay. So in case of addition, you have the 2 types of real part. In case of subtraction of complex number with conjugate, then you have the 2 types of imaginary part. Okay, so these 3 properties here we discuss like with the help of examples, like you have discussed about according to A plus IB and A minus IB, here we discuss about. Okay, now fourth property. Fourth property is Z equal to Z bar. Okay, so since let z equal to a and z bar is again a, so a equal to a. Okay, this is nothing. So this is the same thing, a equal to a. So z is what? Z is purely real. Okay, so no change in which, like same here you discuss like fifth example, you have z plus z bar. Okay, so z is purely imaginary, like you discuss, suppose here z equal to, again here we are assuming like z equal to br. Okay, so z bar equal to minus br, no change. Now here we put br minus br, so resultant what? 0, because this is cancelled out. So this is the purely imaginary, so implies z is purely imaginary. Okay, so there is no change. Now sixth property, here z into z bar, now we have a plus ib and here a minus ib, because bar is this, and now using the identity like a square and minus ib of whole square. So this is the property related to, because I square here, so a square, and now minus I square b square, so a square, and now minus minus is plus b square. Okay, so since we know that I square is minus 1, so this is the real of z whole square plus this is the imaginary of z of whole square. We have the result, there is no change. So these all properties, they are related to the same. Okay, and now here we discuss like z1 into z plus 2 and z1 minus z2 also here we discuss. But in this property, I think with the help of example, I also proved all the properties related to the complex number and discuss like the same 1 to 6 properties. Here we have example, their algorithms, you write down with the different numeric value, there is no change, only you substitute in place of a and b, you have a numeric value, so your operation will be same. In operations there is no change, so you discuss like the same thing for your practice, you do the more practice, you have the example of numeric value and then you write down the property like 1 to 10 and then simplify one by one with the numeric value, but there is no change. Your general term, are you taking the numeric value, result will be the same. So now last four properties are remaining, so discuss about the 4 properties. Okay, then we have to discuss about z1 z2, because before of this here we discuss a particular complex number only, because z only here we discuss. And z with the conjugate of z, we have the more operations related to the purely real, purely imaginary, and so many resultant value we have. But property 7 to 10, they are related with the two different complex number here we discuss, and like same assuming here like z1 and z2, a1 plus ib1 and z2 equal to a2 plus ib2, these two number here we discuss with the properties. So now first here we write down property number 7. We know that property 7 is z1 plus z2 whole conjugate is equal to z1 conjugate plus z2 conjugate. It means you have two different complex number. First you add the different complex number and then find their conjugate. There is no change. Before of this you find separate their conjugate. Are you adding? Resultant value will be same. So now here we illustrate like the example. So let first z1 equal to a1 plus ib1 and z2 equal to a2 plus ib2. Okay, so we have the part like z1 plus z2. So first you add z1 plus z2. Now a1 plus ib1 and a2 plus ib2. Okay, so we have two brackets. Now we add like terms a1 a2, they are added, and now I is common, so you are taking I outside, and b1 plus b2. Okay, so now what? Now you find the conjugate of this z1 plus z2 whole conjugate. And conjugate means what? only the change their sign of iota. Now here iota sign is positive, so after conjugate this sign is negative. So there is no change in a1 plus a2 because a1 plus a2 is here, real here, and then iota this term having, so minus of iota b1 plus b2. Okay, so this is the part of left hand side z1 plus z2 whole conjugate, and now here we discuss like right hand side. We have right hand side is z1 bar plus z2 bar. Bar means conjugate. So z1 conjugate. So z1 conjugate is what? a1 minus ib1. Okay, so and here a2 minus ib2, because first here we find the conjugate and then we add the terms. So result will be same again. We have a1 plus a2 and then 2 result minus ib1 minus ib2. Okay, so a1 plus a2 and minus I is common. So I is outside. b1 plus b2. We have this result. So there is no change. This result is like LHS. Okay, so we have the RHS part and LHS part both are same. So I think property 7 and 8 both are the same thing. There is no change. Only before the minus sign. Okay, so z1 plus z2 or z1 minus z2 here we have. Then there is no change. So otherwise you have the example like the same here. We discuss about the your properties say 8 with the help of examples like numeric. Suppose z1 equal to 3 plus 2i and okay z1 and z2 we have 4 plus 5i. Okay, so now we using the property like you have z1 minus z2. So first we find 3 plus 2i and then minus 4 plus 5i. So result is 3 plus 2i minus 4 minus 5i. Then we have minus 1 minus 3i. Okay, then we find the conjugate of this number z1 minus z2 bar. It is minus 1 plus 3i. Again I explain about the bar conjugate because here z1 minus z2 is a operation, but you find out the whole conjugate of this value. So only change its sign of I. Here minus 3i, after conjugate it is plus 3i. So it change only the sign of I here. Okay, now but this is the only one part is here, and then we have discussed like the right hand side. In right hand side we have z1 bar minus z2 bar, and bar means conjugate. Okay, so z1 is like 3 plus 2i, but here z1 conjugate, it means 3 minus 2i. Okay, because before first here we find the conjugate and then we minus, and then same here 4 plus 5i, so here 4 minus 5i, and then 3 minus 2i minus 4 plus 5i. Okay, so 3 minus 4 is minus 1 and minus 2 plus 5 is 3i. So resultant value there is no change, right on the other left hand side. So in this case we have to clear out, because here we have the general term with the help of some algorithm like part. Here we consider some specific value in form of z1, z2 and z. But here also we have the example of some numeric value. So in result there is no change. This is the generalized form and this is the numerical value. Here we have the example like the same 7 and 8 are both are same. But in one example we have the general terms. In the second example we have the numeric value and then we find out. So in both the cases we have the same result. There is no change, so property is foolproof. So now the same you discuss like same 9th and 10th, and then result will be the same. So I think the concept of conjugate, I think you are aware, and now you remember only one concept you put in your mind. Only in conjugate word is coming in the complex number or any other side, you listen first carefully. If complex number is there and then you listen the conjugate, it means in your mind only you first see the value of I. Value of I is given like plus or minus, you remember. If you find out conjugate, then change their character, change their nature with sign wise. Okay, if positive is there, then you convert into negative. You have the negative iota, then you convert into the positive. So both are very easy. These properties are easy, very easy. Okay, so now here we conclude the topic conjugate of complex number, because so many examples here we illustrate, so many properties here we illustrate, and now properties also we have like with the help of example here we explain. But in all this thing so much easy, because all properties they are related with the sum operations like only plus and minus. There is no new concept inside here, but it depend on you. You do the practice. For the practicing, you don't taking the general terms, you taking the numeric value with the different form, and then try with the properties, and then you find out the sum result value. Okay, in the next video, here we discuss like modulus of complex number. So first you enjoy this video, conjugate of complex number.